Wind energy. This endless non-polluting free fuel has been used in a variety of ways for thousands of years, from grinding grain and pumping water to generating electricity. It played an important part in the development of our western United States. Now, with fuel of all kinds at a premium, researchers are once again looking seriously at windmills, like this 100 kilowatt turbine that can generate enough electricity to power 30 average-size homes.
Okay, pump is up. On control panel number 2.
This control room at the NASA Lewis Research Center's Plumbrook facility near Cleveland, Ohio, is where engineers are beginning to gather information on the largest wind turbine generator operating in the world today. The research is part of a 5-year national wind energy program directed by the Energy Research and Development Administration.
7.5 to 614 to rotate blade. 614 coming up.
The whole purpose of the wind turbine program is to produce electric energy using the wind and to produce it in the lowest cost possible in terms of cents per kilowatt hour. This particular wind turbine is a 125-foot diameter rotor sitting on top of a 100-foot tower. It rotates at 40 revolutions per minute and generates 60 cycle power, the same type of power that you and I use in our everyday homes and so forth.
The highly instrumented wind turbine has strain gauges and accelerometers inside the propeller-like blades, which are read out, processed by computer, and analyzed by the engineers.
Particularly what we're looking for are what are the loads on those blades when the wind suddenly gusts from 10 mile an hour to 20 mile an hour, when the wind goes up over 40 miles an hour. And we want to understand what the loads are on the blades, on the tower, how well the machine holds at constant RPM, and how well it produces the electrical power.
Eventually, the electricity generated here by this wind turbine will be fed directly to the Ohio Edison utility grid to learn the problems of working with an actual utility. More on the long-range plans from Ron Thomas.
Where we're going from here is to produce 2 more machines exactly like this in size, except that they'll be 200 kilowatts instead of 100 kilowatts. We plan to have these machines operating within 14 to 15 months on 2 utility networks somewhere in the United States. In parallel with that, we are going on the design of larger machines, 500 kilowatts to 1,500 kilowatts, and in a period of about 2 years, these machines should be available to locate on utility networks around the country.
A recently completed study indicates that wind turbines in the 500 to 1,500 kilowatt range appear to be the best size in areas where winds vary from 12 to 18 miles per hour. This would allow the production of energy at about 2 cents per kilowatt hour.
As we start talking about building thousands of these machines and improved versions of them using a more advanced technology, I certainly expect that these machines are going to be cost competitive in many regions, particularly where the winds are good and where you're using more expensive fuels such as oil. In fact, I would venture to say that by the year 2000, wind turbines very likely could be producing about 5 to 10% of our total electrical requirements.
Wind power research, applying aerospace technology to an old idea in an effort to help alleviate our country's energy problems.